In this lecture, I want to show kind of the basic way to make any molecular orbital diagram that you'll have to do in this class, and then walk through an example using F2. So for our molecular orbital diagrams, when we build them, we're basically going to build atomic orbitals that can make our molecular orbital. And I like building the whole thing because I think this is just a really satisfying way of representing information about bonding. And a lot of people just memorize the molecular orbital in the middle. And if that is better for you, okay. But it is a lot more fun, I think, to have a whole picture of this. So I'm going to build essentially just a standard one for you to that you can use for other ones. And we'll talk about an exception in a bit, because of course there's an exception. So I always kind of think about this along an energy scale because I'm always showing relative energies of my orbitals, right? We're not going to get into anything deeper than S and P in this class. So we're going to keep everything to that S and P. And these are my atomic orbitals for compound, for atom A, right? Um, Actually, I'm going to get a little picky. I kind of like lighting them up like this. Now I'm going to have two things that I'm bringing together. And this strategy, so molecular orbitals apply to molecules that are bigger than just two atoms. But again, introductory course, we're biting off a small amount first. So I'll take then another atomic orbital, or sorry, element, atomic orbitals, and put it on the right-hand side. So at this point, for each of these atoms, and they might be the same or they might be different, I'll fill in their electrons for their orbital diagram, like I would back when we talked about the electronic structure of the atom. So I'm going to come in and fill in, I guess I'll do a noble gas. I'll just fill them all in. Why not? All right, so now what I'm going to do is combine my atomic orbitals to make my molecular orbitals. And I'm going to focus first on my S, and I'm going to bring those together and have them overlap and create an antibonding and a bonding orbital. So my bonding orbital is going to be lower in energy. And so I'm going to put my molecular orbitals in the middle. Sorry, that looks like moss. These are my MOs in the middle for X2. So, and then it's for every time I create a bonding orbital, I have to create a higher in energy anti-bonding orbital. So these are going to always mirror each other, which is kind of nice. I'm going to adjust my P's up a bit. So now I'm going to combine my P orbitals together. So when I do this, remember I have P orbitals in three different axes. I have them in the Z, in the Y, and the X. And so they're only going to kind of combine with the ones that are in the same axis as they are. So when I bring these together, my p orbitals, I saw I had one sigma bond that was created, or one sigma molecular orbital, and two pi molecular orbitals. So I'm going to bring down that sigma that overlaps directly. And then I'm going to bring down my 2 pi. And these are lower in energy than my starting atomic orbitals because these are my bonding molecular orbitals. And then whatever I do on the bottom, I have to do on the top. So I'm going to mirror this right now. So I have anti-bonding orbitals for pi, and I have anti-bonding orbitals for sigma. And you notice I put my pi at the same energy level. I don't have anything yet that distinguishes between them in terms of like one being higher or lower in energy. And so now I can label these. So looking at this, when I combined my s orbitals, I created a sigma and a sigma star, an anti-bonding orbital. If I want, I can label these S or P, but I'm just going to stick with this right now. When I brought my p orbitals together, I created a sigma bonding orbital and I created 2 pi bonding orbitals. At the same time, when they destructively interfered, I created pi star, an anti-bonding, 2 anti-bonding pi orbitals, and an anti-bonding sigma orbital. So now I have all the molecular orbitals. And if you look, I had 4 atomic orbitals from each that I combined to make 8 molecular orbitals. So I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 molecular orbitals that came from all of my atomic orbitals. So what I combined is what I kind of get out in terms of the number. So then if I was going to place electrons in this, the way I would do it is I would start at the bottom and work my way up. It would look something like I'd place 1, then I'd pair it for a second, then I'd place 2, 4, or sorry, 3 and 4, 5 and 6. And then for my pi orbitals, I half fill first, just like we did with our atomic orbitals, and then I pair them up. And same here. All right. And then I could do something like calculate my bond order by calculating the total number of bonding electrons I had. And so my bonding electrons that I would count would be these ones I'm highlighting in green. It'd be anything that was in a bonding orbital. And my anti-bonding electrons are going to be anything in an anti-bonding orbital. That I've highlighted here in yellow. And the difference between these two would be my bond order, which in this case is 0 because I just filled them with all the electrons. So let's look at an example. Let's look at fluorine. So fluorine has an electron configuration for its valence electrons of 2s2, 2p5. So I'm going to go through and add in those electrons. And what I've done is I've created the atomic orbitals on either side. So I'll have 2s2 and then 2p5 for both of my fluorine. And that's going to tell me how many electrons that I'm going to bring together here in the middle. And I've already recreated the MO format that I had before, but I could combine those here. And so now I have a total of 10 valence electrons, or sorry, not 10, 14 valence electrons. And I'll go ahead and add these and fill them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so I can calculate the bond order now. My bond order is going to be anything that is in my bonding first. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And then my anti-bonding is 1, 2, 3, 4, 5, 6 divided by 2. So that's going to give me a bond order of 1. So this will form a bond. It'll form a single bond. Now, if I look if it's diamagnetic or paramagnetic, I can see that all of my electrons are paired, and so it's going to be a diamagnetic molecule.